Yeah, hi guys. Yeah, I'm here to talk about projects I've been working on called JigLibJS. Yeah, my name's Jim Sangwine. I started out originally in 3D animation. My degree was in 3D animation and my first jobs. But I've been a web developer for around about 8 years now. At the moment, I'm a senior web application developer for comparative IT in Rijswijk, near Den Haag. But in a few weeks, I'll be starting at Philips in Eindhoven. JigLibJS is an open source project. It's a 3D physics engine. And it's currently intended for use with WebGL, but not exclusively. It's just a JavaScript library. So theoretically, you could use it with any JavaScript-driven 3D engine. For example, Google's O3D, which is cancelled development now, but yeah, there's possibilities for the future. And it's actually a JavaScript port of the JigLib Flash physics engine, which in turn was a port of the C library written by Danny Chapman. And so first, yeah, I want to talk a bit about WebGL. WebGL is a new open standard. The idea is to bring 3D to the browser. It's basically a binding to the OpenGL ES standard, which, yeah, if you've ever played any video games on a computer, you've probably encountered OpenGL. It allows hardware accelerated 3D. It uses the HTML5 canvas for rendering. Ooh. And it originally started out as a project between Mozilla and Kronos. Kronos are the people who maintain and develop the OpenGL standard. And Mozilla started a project with them some years ago. Yeah, it was called Canvas 3D, and it was designed to be its own standalone HTML5 element. And other people were working on similar projects. For example, Google was working on O3D, which was a plugin. But now, a lot of the major interests have joined together into the WebGL working group, including Mozilla and Kronos, of course. Google have come on board. Google have now cancelled development of O3D, and all of their efforts are focused on WebGL as well. Opera and Apple are also in the working group. And yeah, the important point is that it's an open standard. It's not a plugin. There's already a lot of solutions out there for doing 3D in the browser. Flash with the Papervision libraries, for example. The Unity plugin, Google's O3D, which I've already said has been cancelled now. So the idea is, of course, in the future that any standards-compliant web browser should be able to run WebGL. That's the vision. At the moment, yeah, the public officially can't use WebGL because it's only available in the nightly beta builds of Google Chrome, Firefox, and Safari. But all three of those browsers will be including WebGL support as standard in their next major public releases. Mozilla's also been adding WebGL support to Fennec, their mobile browser, which is available for MIMO and Android devices. It's also still in beta, so you have to access the developer builds to be able to use it, which you can get from here. But I've made a convenient video to show you it running. You can see that the acceleration still isn't quite up to speed, you know, this is in development software. So, yeah, for the future support of WebGL, I think it's reasonable to expect that Apple will include WebGL support in their iOS devices because, yeah, they're so heavily involved with the WebGL project. They've already got support in Safari, their own WebKit. And that's going to open up a serious number of extra devices that we can run the software on. iOS has already got very considerable penetration. But there's one major browser that really has no plans to support WebGL. I think we can probably guess which one that would be. And some people, might worry that this is a bit of a game breaker, because although, according to W3, IE is losing ground against the other browsers, it's still around about 30% of all of the users, according to W3. But there's a possible solution. Google's been developing a plugin called Chrome Frame, which basically allows any tab or window in Internet Explorer to render using Google's Chrome engine, as opposed to the standard built-in IE engine. It enables full, obviously, HTML5 support. It uses Google's JavaScript engines, and, of course, WebGL. And just recently, they managed to get it so that it would install without admin privileges. So, yeah, that's pretty important, I think. All the people that work for large organizations and are currently locked down to Internet Explorer 6 or some other version of IE, they can install this plugin. And, you can put a small amount of JavaScript code, around about 3 lines, into your pages, so that when someone hits your application, it'll just pop up just the same as it would with Flash, a plugin install prompt. They can hit the button, it'll install transparently, and then off they go, and they can view your content fairly seamlessly. Chrome Frame already supports WebGL in the dev channel. I had to contact Google to ask them about this, and they've given me the URL there to the currently supported version. And Chrome Frame will officially support WebGL when Chrome also does, which, as I say, will be in the next version, next major public release. And here I've got an example at one end of the spectrum. This is Internet Explorer 9 beta, the very, very latest from Microsoft. And this is just a test page. You can see here that the rendering engine's Chrome Frame, and there's a nice HTML5 video element up there. And here I've actually got a video of Internet Explorer 6 running a JigLib demo. It's pretty poor frame rate and quality because it was running in a VM, but we can see it's working. And of course, this is pretty useful for anyone who's producing any kind of HTML5 content, not just 3D and WebGL. So what can WebGL do? As I say, it's 3D in the browser. I've got a couple of nice little demos here. This is one produced by Google, available on the Google Code site. It's just rendering a lot of blades of grass. And as you can see, it's real live, properly rendered 3D. It's not a video or so. And it's actually shifting quite a lot of data there. This is, this is a particularly nice demo. This is a Quake 3 tournament level, running again in WebGL. I'm not sure you can see that particularly well, but we're soon going to be able to get pretty full-featured games running in the browser. Yeah. It's another nice little demo. This, I think, shows off quite nicely the render quality you can achieve if it catches up. Yeah, usually that runs a lot better. I think it must be... but anyway, that's showing off quite a few fairly advanced 3D effects there, light occlusion, depth of field. And yeah, really this I think shows that is the full OpenGL standard that's being supported. And so pretty much anything that you can see in mobile games, desktop games using OpenGL for their rendering engine is going to be possible in the browser. And I think it's also going to be important for interface design as well. I think people are going to start using 3D effects in their simple website interface designs. We've got here a nice 3D photo gallery browser. This is pulling results directly from Google Images. This is from Cool Iris. And I think it really has potential to add something to the user experience on the web. I think that personally, that 3D is going to really change the way that we use the web. I think it already is with WebGL. The various browser manufacturers I've already talked about have already started changing the JavaScript specification to help deal with the kind of load that's involved in handling complex 3D scenes. Particularly, they've added a new set of data types, typed arrays, which are designed to be able to very quickly handle large amounts of data, very fast seeking, and these are very useful for storing mesh coordinates and very heavy data sets within JavaScript. And also, now that we're changing the way that we're using JavaScript, the browser vendors are beginning to put more and more effort into streamlining and optimizing their JavaScript engines. Just a few weeks ago, Mozilla released their new JagerMonkey engine, which is significantly faster than TraceMonkey. And I think that this is something we're going to keep seeing. I think there's going to be a lot of effort put into JavaScript from now on. Of course, any new web technology has to be commercially interesting. And I think we all know that already entertainment on the web is a pretty big business, with sites like YouTube and social networking sites, that kind of thing. And also, it's going to change the way that the internet development flows now, because historically, for rich media, we've been at the mercy of third-party plugin developers. You're kind of waiting for people like Flash to add feature support, and then you start seeing those features being implemented on the internet. If we can move away from that model and have standardized support within browsers, I think that we're going to see more rapid development. We're going to see more development-led development, if you see what I mean. And also, 3D's had a real impact in the desktop and console worlds. Video game sales nowadays are massively greater than they were in the days of two-dimensional video games. And I feel personally that 3D is also going to have the same kind of impact on web and web applications. I think that users are going to respond well to it. So yeah, ultimately, is it commercially attractive? If you look at casual gaming on the internet, it's already an absolutely enormous market. BigFishGames.com gets 11 unique visitors a month. And earlier this year, Zynga had 250 million active users a month just via Facebook, not counting their own site, of which more than 80 million were Farmville users, and they were taking revenue well in excess of $1 million a day, around about 600 million a year. And obviously for marketing, advertisers are always looking for ways to get their content noticed by people. They want to make more and more attractive content. And particularly, there was a company I was looking at about a year ago, and they're working on developing 3D marketing games for different companies and product lines. And they were using augmented reality and the Flash and the Paper Vision libraries to create, small games for websites as an extra, marketing stream. And I think with this amount of interest in this kind of technology, perhaps even Microsoft will jump on board eventually. And the good news is they haven't announced any plans to roll their own 3D engine. So I think we've got hope for native Microsoft Internet Explorer support at some point in the future. So back to JigLibJS. It's essentially a research project. Obviously, it's also a product that people can use. It's it's a library that's designed to be used. But the aims for the project were mostly research-based. The project's actually supported by NLNet, who fund high technology projects in the Netherlands, and Comparative, the company that I work for. The original port of the engine was started by a guy called Paul Brunt, who is the author of a GLGE, which is a really nice library to ease the use of WebGL. WebGL, for the novice user, can be pretty heavy because it's a lot of shader programming. OpenGL's pretty hardcore. And so several people have started developing really nice wrapper libraries that massively simplify the use of WebGL. One of the best ones is JLGE. And yeah, pretty coincidentally, a few weeks before I started on this project, Paul had already had the same idea, and he got in contact with me, and we've been working together since. So the aims of JigLibJS is to allow easy implementation of rigid body physics simulations. So, you know, again, it's a kind of wrapper library. It's designed to greatly reduce the barrier for entry in implementing this kind of technology. And as I said, it was a research project, so one of my main aims was to test the modern JavaScript engines to see if they could handle this kind of load, because people like Google particularly were speaking out against WebGL in the beginning, saying that JavaScript simply isn't fast enough to be able to handle this level of computation, you know. So, you know, that's been a major thing from the naysayers. So, yeah, that was an important thing for me, was, you know, to really see where the limits are at the moment, actually. And also to stimulate community interest in WebGL. It's a technology I'm passionate about, and yeah, I'd like to be able to help get people involved in it. So the current status of the project, we're getting on pretty well. This is a demo you already saw running briefly in the IE6 VM, but this is it at full speed. So we've got box and sphere collisions working quite nicely now. Still need some tweaking. And you can see, as you get too many objects in the scene, you start to get some penetration between the objects because you know, it's just exceeded the limits of the JavaScript engine. It can't quite keep up. So, you know, unfortunately, already quite quickly, we're hitting the boundaries, which is a bit of a shame. But I think this is going to improve drastically in the future. We've got point constraints working. So here I'm able to control the red sphere at the head of the chain, and each of the other objects have a single point on their surface, which is bound to a point on the surface of the objects in front of them. And this is going to be particularly useful for skeletal animation, ragdoll physics, that kind of thing. We've got vehicle physics working at last. We had quite some bugs with this. This is a demo that was built up by Paul Brunt, the chap from JLGE. And yeah, what you're seeing here is a true vehicle physics simulation. There's, you know, I'm not physically animating forward the vehicle when I push the buttons. The wheels are actually turning. The wheels are bound to the body. There's friction going on between the wheels and the surface of the ground. So, you know, this is the kind of thing that could be built on to produce the sort of racing games that you see on other platforms. And I've been starting to expand the library beyond the original ported version. I've been adding in some basic effects. This is a simple wind effect. So with these sliders, I'm just going to be controlling a wind effect in each axis. That's all working pretty nicely. We've got an explosion or concussive force kind of effect, which can be bound to any object. You can place it physically somewhere you wish within the 3D world, or you can bind it to an object that is also involved in the physics simulation. So you'll see, yeah, the red ball in there is the one that has the effect bound to it. And I've just recently added reactive force as well. So the body that's causing the effect is also, you know, receiving reflective effect from the objects that it's influencing. You can increase the radius and the force of the effect. And the final effect I've been working on recently is gravity fields. And again, this is an effect that can be bound to objects within the scene. I've used fixed position objects for this demonstration, but they could also be involved in the physics simulation also. And so I'm just going to increase the radius. Actually, I'll do the strength first. So I'm working on the left ball here. I've just upped the strength, and now I'm going to gradually increase the radius, and you should see it start to grab the other rigid bodies within the scene. And of course, the effect can work in the opposite direction as well, and have a repelling effect. And finally, a guy called Matti Antonen, quite early on in the project, already went and made his own game using JigLibJS, which is pretty cool. This is his blog site, lively3d.com. And he's made a little mini golf game. It's really nice to see that people are already using the library. So the results so far. I feel that browsers are capable of handling fairly complex physics simulations already. As everyone knew it would be, JavaScript isn't as fast as C or even ActionScript at the moment. But we can already do a lot, and as I've already said, I think it's going to get a lot better with the future. So I thought I'd just walk you through a simple JigLibJS implementation. We're talking straight HTML here. So the first thing you need to do, of course, is include the libraries, and that's the first to include at the top. I'm also using GLGE as the wrapper here to simplify the code. You need a HTML5 canvas element to actually render the content. And this is the way that GLGE, or one of the ways that GLGE can handle importing scene data. These are mesh coordinates. Each of these coordinates here reflects a single vertex point of a given 3D object in the scene space. Looks pretty complicated, but this kind of stuff you can export from pretty much any 3D web application, particularly Blender. Blender's the open source 3D app. And there's already a plugin available for that, which will allow you to export for GLGE and also a couple of other open source WebGL frameworks that are available already. So it's just a case of building your meshes up in Blender and hitting export, and off you go. GLGE also continues to use XML for defining the actual scene elements as well, not just for importing the meshes. So here we're setting up a couple of shaders. The first two are just simple colored shaders, and the third one is an actual text shader, uses a bitmap for its mapping. All pretty simple stuff. And then you can go ahead and actually start to set up the basic scene in the beginning as well, the background color for the 3D scene, that kind of stuff. And you can see here we're setting up a camera, defining the ground object, and we're applying the textured grid material to the ground surface, and then putting in initially a single sphere mesh, which is just an instance of the sphere mesh that we defined in the previous step. And again, it's assigning one of the shaders from the XML above. And then it's just a case of starting up some pretty simple JavaScript, getting a couple of object references, setting up the renderer, the GLGE renderer, and passing to it the HTML5 canvas element, and then grabbing a reference to the XML doc. Continuing to set the scene up here. So now we're grabbing the main scene element from the XML doc, which was the bit we just set up with the cameras and the mesh objects and everything in it, and getting the renderer ready to go. And then in order to be able to use the GLG objects in your JavaScript code, you can just grab references to them straight from the XML in this manner here. And then one of the important steps here is you need to define links between the JigLib physics bodies and the physical mesh objects, which are defined in GLGE. So we just set up a simple array here to maintain those relationships. And I've put in a simple on-key down handler so that you can physically control the object within the scene. And I'm referencing here a uSphere object which we haven't defined yet. That's going to be the JigLib object, which matches the single user sphere that we put in the XML. And then, just calling an add sphere reference there as well. So this is a simple method that we've put in to allow the user to spawn 3D objects into the scene. And the first step is to create a GLGE mesh object. And this is the other way you can work it. So you can just call a reference to the spherical mesh, which was defined in the XML, and then spawn new objects into the scene just by adding the objects there. And then the second part of the process is creating a corresponding JigLib body, which will control the physics for the mesh objects above. So it's just JigLibJS. And you can set a few parameters here like mass, friction, position it within the scene. And then I'm just pushing into the links array that I talked about earlier. So just an associative object. So GLG is the new objects and the JigLib objects is the sphere. And then later on we'll bind together the properties of those two objects. Okay, now we're again creating JigLib bodies to match the GLG objects that were defined earlier on in the process, right up in the top in the XML. So first we're just creating a simple plane surface which matches the ground objects from GLGE, and we're creating the single user sphere which we're going to bind to the other one that we created in the XML earlier, and that's the element that will be controllable by the user. And then finally pushing the links in so that those objects can be bound together in the render process. And then just a simple render scene method. This just goes through, integrates the system, that's the physics bit. And then also within the render loop, we just get the current position of the JigLib objects and we pass that on to the physical mesh objects from GLGE so that the physical meshes actually follow the objects from the physics simulation so you can see what's going on. And then just a simple set interval timer setup to iteratively call the render method, and that's it. And what you end up with is this simple setup here. So the user's got their own sphere which they can control, and then when they hit the space bar they can spawn some other objects which all work nicely. So it's pretty easy to use. Yeah, we're looking for help, as with every open source project. There's quite a lot of stuff that still needs fixing. We're having problems with cylindrical collisions at the moment. The code needs further optimization, so anyone who's into JavaScript optimization in a big way can for sure help. And also particularly people who are into 3D maths, actually, if anyone knows anything about that stuff. And we need some good documentation writing. And we need people to make some cool stuff. You can get to us via Twitter. And I've just got a couple of useful little links here. That's the JigLib main project site. That's our Twitter ID. GLGE is the wrapper library that I was using for most of those demos. Learning WebGL is a great resource for getting into this stuff. And that's the official Khronos wiki. And that's it.
Very nice. So when do you expect the next releases of these browsers?
Of the major browsers, yeah, they won't tell me, unfortunately.
I think for Firefox they'll be in 4.
Yeah, Firefox version 4. 4.07 beta 3 is the current one, I think, and yeah, it's all looking pretty good. I'm not sure. But yeah, like I say, they won't tell me where they're up to or when they're going to officially release. But it should be pretty soon, I think. Yeah, I think so.
Is there some sound support of music, or that's?
Yeah, I believe that Paul's put some sound support into GLGE. And yeah, for sure, you know, there's no reason that you can't mix in video and sound with this kind of stuff. You know, the HTML5 canvas element already supports video. I saw some pretty cool demos from Paul Roget of Mozilla showing overlay effects with video in the canvas element, image compositing, all of that kind of stuff. So yeah, you know, there's no reason why you couldn't, you know, lay 3D over the top of existing video elements, use the sound. Yeah, absolutely, yeah. I mean, this is just simple JavaScript and HTML, you know, so it'll work with any other technology, any other existing browser technology.
Yeah, I'm not really well known with OpenGL development myself. What is the spheres? Will the smoothness automatically be better if the processor is faster, or?
Yeah, well, that's something called level of detail, which has also been built into GLGE. You can define different meshes for the system to use depending on the proximity to the camera. That's an effect that's used in video games a lot. So if something's further away, you can load in a much simpler texture and mesh for that object because, you know, it's so far in the distance you can't see it properly. And then as they get closer to the camera, you can progressively upscale the complexity of the object. So that's something you can certainly do.
But it's not automatic?
No, no. No.
Because that's in a web environment very important.
Of course,
you never know what the consumer has.
Yeah, absolutely. Yeah, yeah. Yeah. Well, yeah. I guess you could pretty simply, you know, monitor the frame rate that the application's being able to render, and then substitute simpler meshes as necessary. That's something you could certainly program. Yeah, and fairly easily as well, I would say.
If it's easy, then we'll put in the library.
Maybe. Yeah, I'll suggest it to Paul. JigLib is just the physics, and it's the other libraries like GLGE that actually handle the rendering and simple generation of meshes, that kind of thing. But yeah, that's something I'll suggest to Paul maybe. Yeah, that's a nice idea.
Yeah, for the presentation, by the way, maybe it's easier to use other colors. Blue and black are a bit difficult to see.
Okay, sure. I use those because they're the colours from the website.
Yeah.
Okay.
Impressive.
Yep. Well, thanks for watching.
Mhm.